Thanks a lot. Well, let's officially start. Welcome, everybody, and a particular welcome to Elliott Sober. I've been reading your work, Elliott, for more than 40 years, I think. So it's a great pleasure to meet you virtually, at least. And I very much look forward to your talk. As everybody here knows, that Elliott is one of the leading philosophers of biology and has made a huge contribution to the kind of thinking that we've been discussing in this group. So welcome, Elliott. We very much look forward to your talk.
My pleasure. Thank you for inviting me. So my topic today is what did Darwin think about group selection? And I'm going to be going against what seems to be a widely held view that he rejected the idea. And then I'm going to jump forward to a 20th century idea from statistics called Simpson's paradox, which I think is really key to understanding the intelligibility of the idea that group selection can cause altruistic characteristics to evolve. Darwin didn't know anything about this, but I think it helps clarify why the idea is not crazy. So let me begin. So here's some background. You'll recognize the names on this list. Helena Cronin refers to the individual level orthodoxy of Darwin, Wallace, and their contemporaries. Richard Dawkins describes biology in the 60s as struggling to regain Darwin's ground, which is the position that Dawkins calls the selfish organism. And finally, Michael Roos says, apart from some slight equivocation over man, Darwin opted firmly for hypotheses supposing selection always to work at the level of the individual rather than the group. These individuals view group selection as a colossal blunder, something that really poisoned evolutionary biology, but then was rescued. And fortunately, Darwin, all of our hero, did not make that fatal mistake. I think this is bad history. So let me begin with some terminology. Individual selection, by that I mean selection within groups, where selection favors traits that are better for the individual over traits that are worse. Group selection is selection among groups, where selection favors traits that are better for the group over traits that are worse. And of course, better and worse means always the effects on fitness, survival, and reproduction. And the standard example of this in the 20th century, and it really was the main kind of example that Darwin himself was thinking, was this the example of altruistic versus selfish traits. These are not psychological categories. These are categories of behavior or just traits that have two kinds of fitness effects. An altruist donates a fitness benefit to someone else at cost to itself, and a selfish individual makes no such donations, though of course it can be on the receiving end of donations from altruists. More mathematically, this is a good way of visualizing how altruism and selfishness are related. You'll see that no matter on the x-axis, you see the frequency of selfishness in a group. It could be anywhere between 0 and 100%. And no matter whether altruism or selfishness are common or rare, the S individuals are always fitter than the A individuals. If you're in a 50% group, S is fitter than A, and so on. However, the W bar line represents the average fitness of individuals in a group, which is also, in the cases we'll just be discussing, a good representation of what group fitness means, how productive the groups are in producing offspring, individuals. And you see the W bar goes downhill as selfishness increases, and that represents the idea that altruism is good for the group and selfishness is bad for it in terms of fitness. And so what we can do is see that individual selection will be, as I said, is selection within groups. And in groups in which there are selfish and altruistic individuals, individual selection will favor selfishness. Selfish individuals are fitter than altruists in the same group. However, the group level selection among groups, it'll favor groups that have larger concentrations of altruism over groups that have a less strong concentration. And when there is variation in fitness, both within and among groups, both group selection and individual selection are at work. So we have two kinds of selection processes going on, and you see they're kind of in an antagonistic relationship. The trait that's promoted by one type of selection is opposed by the other. Here are the examples that I want to talk about from Darwin. There might be a few more about, these are the ones that I know about. The honeybee's barbed stinger and worker sterility and social insects from The Origin, human morality from Descent of Man. And then there's a fourth one, which is less familiar in the literature on this subject. And Darwin didn't have the word altruistic. That entered French by Auguste Comte in the middle of the 19th century. But he had the idea that these traits are all involve a fitness cost to the self and a fitness benefit to others. So let's see what he says about these. Here's the honeybee's barbed stinger. And Darwin asks in The Origin, can we consider the sting of the wasp or the bee as perfect, which when used against many attacking animals cannot be withdrawn owing to the backward serratures, the barbs, and so inevitably causes the death of the insect by tearing out its viscera, ? And his answer is, if on the whole the power of stinging be useful to the community, it will fulfill all the requirements of natural selection, though it may cause the death of some few members. So because it's good for the group, that's why the barbed stinger evolved. That's the answer that Darwin gives. Here's a more familiar example, perhaps the most familiar example from Darwin of this discussion of altruism on human morality. He says it's extremely doubtful whether the offspring of the more sympathetic and benevolent parents, or those which were the most faithful to their comrades, would be reared in greater number than the children of selfish and treacherous parents of the same tribe. He who is ready to sacrifice his life, as many a savage has been, rather than betray his comrades, would often leave no offspring to inherit his noble nature. The bravest men who were always willing to come to the front in war and who freely risked their lives for others would on average perish in larger numbers than other men. So the problem is, how do we explain the evident fact about human cultures that human morality often requires self-sacrifice for the benefit of the group or for the benefit of other individuals in the same group? And here's Darwin's solution to that puzzle. He says, although a high standard of morality gives but a slight or no advantage to each individual man and his children over the other men in the same tribe, yet that an increase in the number of well-endowed men and an advancement in the standard of morality will certainly give an immense advantage to one tribe over another. A tribe including many members who, from possessing in high degree the spirit of patriotism, fidelity, obedience, courage, and sympathy, were always ready to aid each other and to sacrifice themselves for the common good, would be victorious over most other tribes, and this would be natural selection. At all times throughout the world, tribes have supplanted other tribes, and as morality is one important element in their success, the standard of morality, the number of well-endowed men, will thus everywhere tend to rise and increase. And the third example has a significance in Darwin's career that goes beyond the question that's my subject today of what he thought about group selection, but it's something that stumped him and caused him to really go into turmoil in the 1850s. And it was what he knew to be the fact that workers in many social insect species are sterile. And he says in The Origin that this is by far the most serious special difficulty which my theory has encountered. And the puzzle to start with is that how can the trait of sterility evolve by natural selection if individuals with the trait cannot pass it along to their offspring? It's not like zebras running fast, where faster zebras have more offspring than slower zebras, and therefore the frequency of fast zebras will increase. It's not like that. And Darwin began his thinking about this by thinking of an analogy with artificial selection. So suppose a farmer slaughters several beef cattle and finds the one that has the best tasting meat. How can the farmer use artificial selection to improve the flavor of the beef his herd produces? He's just killed the tasty individual that interests him. And Darwin knew from the way plant and animal breeders behave is the farmer chooses the parents or the siblings of the cattle with the best tasting meat to be the parents of the next generation. So the lesson from family selection for Darwin was to understand the evolution of sterile workers or the tastiness of beef. Think about the parents that produce offspring that are sterile or taste good. And let me now turn to the example at hand, sterile workers in the social insects. Here are two strategies that a fertilized female could use. She could be an all F individual. She could have 10 fertile offspring. Alternatively, she could be a mixer. She could have 9 fertile and 1 sterile offspring, where we're supposing that the sterile individuals help other individuals in the same nest. Now, suppose, for a simple example, that each nest is founded by 2 fertilized females. That means there are going to be 3 kinds of nests. They can contain 2 mixers. They can contain 1 mixer plus 1 all F individual, and they can contain 2 all F individuals. Within nests, what's going on there? Well, there's no individual selection in 2 types of nests because there's no variation. In the 1+1 nest, there is. And what will happen there? Well, in a 1+1 nest, mixer's sterile offspring helps its own siblings, but it also helps the offspring of the all F foundress. So you can see right away that the all fertile individual the individual receives a benefit from the mixer. So you can see the hallmarks of one of the first hallmarks of altruism present here, that being all F is a selfish trait, and being a mixer is an altruistic trait. So within nests, there's no individual selection in 2 of these, and in the one in which there is variation, individual selection favors all fertile offspring over mixing sterile and fertile offspring. But between nests can differ in their productivity, and the more mixers that are found in a nest, the more productive the nest is. Supposing that's true, group selection will favor the mixer strategy, that is, having 9 fertile and 1 sterile offspring. And here's what Darwin says about this example. With sterile neuter insects, we have reason to believe that modifications in their structure and fertility have been slowly accumulated by natural selection, from an advantage having been thus indirectly given to the community to which they belong over other communities of the same species, group selection. And here's the 4th example, which is is charming in a way. It's from The Descent of Man. He's talking about technological innovation. Here's the example. He says, now if some one man in a tribe, more sagacious than the others, invented a new snare or weapon or other means of attack or defense, the plainest self-interest would prompt the other members to imitate him, and all would thus profit. If the new invention were an important one, the tribe would increase in number, spread, and supplant other tribes. Alex Rosenberg drew my attention to this cool example. It's easy to imagine that being an innovator is not an altruistic trait. It's true that innovators share or perhaps sell their innovations to others, individuals, but they gain prestige, and that might be a benefit that outweighs the cost of sharing, if there is a cost of sharing. And in that case, innovators will be fitter than non-innovators in the same tribe. Let's just explore that as a possibility. Darwin actually doesn't go into this question of whether innovators get a benefit from being innovated from members of the same tribe. Here's the picture I showed you before of how altruism and selfishness are related. Under the scenario I'm considering, being a technological innovator is not an altruistic trait. It's like this, that innovators are fitter than non-innovators in the same tribe, and groups with innovators do better than groups without innovators. So innovation is not altruistic. It benefits both the group and the individual as well. So this would be an example in which group and individual selection are pushing in the same direction. It's not like altruism and selfishness, in which group and individual selection are in opposition. It's important to draw a distinction here because of this example between cultural and genetic group selection. In genetic group selection, selected traits are transmitted to the next generation by genes that cause those phenotypes. In cultural group selection, selected traits are transmitted to the next generation by imitation, teaching, and learning. And it's plausible to think that innovation in technology is transmitted culturally, not genetically. And I would say that that comment also applies to human morality. It's plausibly transmitted by cultural group selection. So here's Darwin's big picture. He thought that group selection was important, though he did not think it explains everything. Many traits evolve because of individual selection alone. Darwin thought that altruistic traits evolve because of group selection, though he thought that non-altruistic traits sometimes evolve by a combination of group and individual selection. And with respect to human beings, Darwin thought that group selection was particularly important in the evolution of our species. Okay, so let me now fast forward to 1951 and Edward Simpson's invention of an idea that got called Simpson's paradox, though true to form, he didn't really see this idea for the first time. Carl Pearson and Udny Yule also had this idea, but not in connection with altruism. So to give you a feeling of what Simpson's paradox involves, I'm going to change to an example that has nothing to do with evolutionary biology, namely the somewhat well-known case of sex discrimination at Berkeley, University of California in the 1970s, and describe how Simpson's paradox was exemplified in that example. And then I'll come back to the evolution of altruism. Okay, in the Berkeley case, what was first observed was that women were admitted to graduate school less frequently than men. And this suggested the hypothesis that departments were discriminating against women. But when the investigation was done, what was observed was that the admission rates of women and men were the same in each department. And what I hope is puzzling you, if you're not already familiar with Simpson's paradox, is how can these two statements be consistent with each other? How can they both be true? If women were admitted were admitted to grad school less frequently than men, surely some departments must have admitted women less frequently than men. So what's going on here? Simpson's paradox is the example. So let me walk you through a super simple example of the Berkeley situation. This is a hypothetical university which has two academic departments. Men and women apply, 1,000 men and 1,000 women apply to each department. You see most of the men apply to the second department, most of the women apply to the first department. And suppose these are the admission rates in the two departments, and notice that neither department discriminates against women or in their favor. The admission rates for men and women are the same in each department. If you multiply the second table by the first, you see that 20 males were admitted to Department 1, 180 were admitted to Department 1, and so on. And what you can see here is the surprise that in the applicant pool, 50% were males and 50% were females. No discrimination in the admission rates. And look at what happened to the total number of men and women admitted. 380 males were admitted and 220 females were admitted. So women were admitted less frequently than males, even though each department did not discriminate. And this is an example of Simpson's paradox. The rough idea here is that what's going on within each department doesn't capture is different from what's going on in the university as a whole. The departments aren't favoring women over men, but the universities did just that. No, did the opposite, favored men over women. And the reason this can happen, and it does happen in this example, is there's a correlation between being a woman and applying to the second department. And what I mean by correlation is this, that the probability that an individual applies to the second department, if they're female, is greater than the probability they're applying to the second department if they're male. Now let's do the same little thought experiment with respect to altruism and group select and the evolution of altruism. And we'll imagine there are two groups, each has 1,000 individuals. Most of the selfish individuals are in group 2, most of the altruists are in group 1. Here are the fitnesses of individuals in each of those 4 circumstances. That's the number of babies that a selfish individual has in group 1 and so on. And when you multiply the 2 tables together, you get the result that in the next generation, you have these numbers. And notice what's happening here is that in the first generation, in the meta population composed of the 2 groups, altruism is at 50%. But notice in the next generation, when you total things up, there are 2,800 altruists and only 2,200 selfish individuals. So altruism has increased in frequency in the meta population, though within each department, altruism is declining in frequency because 4 is bigger than 3 and 2 is bigger than 1. And the reason Simpson's paradoxes arises here is, again, because there's a correlation between being an altruist and being in a group with many altruists. Altruists are mainly living with each other. Selfish individuals are mostly living with selfish individuals. That's what allows Simpson's paradox to arise. And as I said, in this example, and this is I think, the part that makes the word paradox very appropriate. It seems crazy to say this, but it's true that altruism declines in frequency within each group, but it increases in frequency in the 2-group ensemble. And I don't mean this to be, this is a fact about the example, the 2-generation snapshot that I've given you here, that the direction of change within departments is opposite to the between groups. Let me start again. The direction of change within groups, altruism going down in frequency, is not the same as the direction of change in the meta population of the 2 groups together, in which altruism is increasing. Well, that's just like I said, 2 generations, 1 generation, the next generation compared. What will happen in the long run here? Well, if the 2 groups hold together, they don't found new colonies, new daughter colonies. The frequency of altruism in each group will go to 0, and therefore the frequency of altruism in the meta population will also go to 0. And what this means is not that altruism can't evolve, but if it's going to evolve and be maintained, groups need to found daughter groups and do so fast enough to overcome what's going on within each group. So groups have to have babies just as individuals have to have babies. So here's an argument that on its face seems compelling, and it tells you that not only can't group selection cause altruism to evolve, but natural selection in general cannot cause altruism to evolve. And I think something like this argument was very influential in guiding the intuitions of biologists and non-biologists when they thought about whether altruism could evolve by group selection or by selection at all. Okay, the argument has two premises. The first is when selection controls the evolutionary process, fitter traits increase in frequency and less fit traits decline. Second premise, when altruists and selfish individuals are in the same group, altruists are less fit than selfish individuals. And the conclusion is drawn that natural selection cannot cause altruism to increase in frequency. Notice that the conclusion is not about group selection or anything. It's just about natural selection in general. I think the premises in these two arguments are both correct. The second one is part of the definition of altruism. And the first one is, I just take it as a stipulation that if selection is in control, fitter traits are going to increase in frequency. So what do we make of this argument? But it's only a partial picture of what's going on if you want to talk about natural selection. Ignores fitness differences among groups. And when you change that and make that explicit, and say that when altruism and when altruists and selfish individuals are in the same group, the altruists are less fit than the selfish individuals, true by definition. And what follows from that is not that selection can't cause altruism to increase in frequency, it's just that individual selection can't do that, which of course is true. Let me to give you a feeling about what it takes for altruism to evolve. Let me talk about the special case in which each group has two individuals. It either has two altruists, two selfish individuals, or one of each. And what I've described in this 2x2 table is the fitnesses of individuals, whether they're altruistic or selfish, and whether their partners are altruistic and selfish. And you can see in this table that if you, regardless of whether your partner is altruistic or selfish, you do better by being selfish than by being altruistic. But now let me take the table and not just write the payoff to you. I'll put the payoff to you and your partner together, where row comes before column in these in this new 2x2 table. Each individual, if they're both altruists, each has a fitness of 3. If they're both selfish, each has a fitness of 2. And if one is selfish and one is altruistic, the selfish individual has a fitness of 4 and the altruist has a fitness of 1. Now look at these this second table and look at the total fitness of the three kinds of groups. Altruistic groups in which individuals are both altruistic, have a fitness of 6. Selfish groups have a fitness of 4, and mixed groups have a fitness of 5. So you can see here in this example how altruism, the more altruists there are in the group, the fitter the group is, familiar from before. But now consider the idea that altruists live mainly with other altruists and selfish individuals live mainly with other selfish individuals. That means that altruists will have a fitness pretty close to 3 rather. Altruists will have a fitness of 3 in that context. And if selfish individuals mainly live with selfish individuals, they'll have a fitness pretty close to 2. So you can see here how altruists on average can have a higher fitness than selfish individuals, though altruists are always less fit than selfish individuals in mixed groups. Thanks for your attention.
Well, thanks very much indeed, Elliott. That's really stimulating, taking us through that. Any questions or comments? Anyone wish to raise their hand?
I believe Kevin had a comment in the chat there, Jeff.
Okay, Kevin, would you like to come in?
Hi, yeah, just thanks a lot, Elliott. Great to hear your talk. So I appreciated the integration of innovation as an idea. And the question I put in the chat was, it seems like maybe a rosy assumption made about innovation being individually beneficial. And I just wondered what you think about that, because there's plenty of evidence of innovation being costly, or at least highly varied in terms of outcomes for the individuals.
Yeah, I don't want to disagree with that. And if that's true, then innovation will be an altruistic trait and will be subject to the same puzzle that arises in connection with sterile workers and barbed stingers. But I thought it was worth considering the idea that innovators might gain from being innovators. So you're right. It's an empirical question. Of course, different examples might lead to different conclusions there.
Well, and I was amused because if you take Campbell's blind variation as a kind of innovation, then it's not costly necessarily anyway. But
well, there's the I think, is Campbell talking about just an individual thinking and coming up with ideas kind of at random to contemplate?
Others here have a lot of thoughts on this, but I think blind and random we can tentatively treat as equal.
Okay, so yeah, maybe there's no cost to daydreaming, although but there could be benefits as you sort through the different dreams. That makes sense.
Great, thanks.
Okay, David, I see your hand up.
Great. Is my mic on? Can you hear me?
Yes, we can hear you.
Okay, so Elliott, of course, we go back a long way together, and that's my question actually. So this was, I guess I have two questions. Why did good scholars such as Michael Ruse or anyone else say that Darwin didn't invoke group selection when he did invoke it so clearly? And then my second question is, what's the current situation? I mean, is this now the consensus, or is there some sense in which there's been some kind of cultural stasis within the academic field? And so even today, after all of this, more or less being presented, I mean, we're talking 45 years ago, that there's still some kind of climate of opinion that and a lack of literacy, basically, on what group selection is. So if you could reflect upon both why people like Michael Ruse could have interpreted things otherwise back then, and anyone in this group, what the current state of opinion is. Is this all accepted now? I'd love to think that the answer is yes, but I worry, and I have experience that the answer is no.
Yeah. Right. I think that part of what was going, I'm going to have to psychologize here a little bit. I think part of what was going on with these scholars is that they absorbed from their biology colleagues the idea that group selection is not just wrong, it's stupid. And it's worse than being false. I mean, it's just a pernicious idea that poisons the scientific enterprise. And if you buy that and you think that Darwin was a genius, it's very easy to think, well, he couldn't have done anything as stupid as that. And and then if you bother to look at the text, then you have to explain away what he seems to be saying by saying that he was just being sloppy inadvertently. He said it's good for the community rather than good for individuals or something like that. So I mean that's a psychological speculation, which I mean I don't know how seriously one should take that. But I think there's something to it. As far as the current opinion, I think it depends on which communities you're talking about. Are we talking about biologists? Are we talking about philosophers of science? And geography matters a lot too. Are we talking about people in the UK? Are we talking about in the United States or other countries? So my impression in philosophy of biology is that the idea that group selection is a legitimate scientific hypothesis and has to be tested on a case-by-case basis is very, I won't say everybody believes it, but it's a very mainstream idea among philosophers. And my experience with biologists, less comprehensive than yours, of course, David, leads me to think that that's absolutely not the situation in biology. So you should speak to the biological social question.
As many people here know, that we have a whole multi-level selection initiative, which is resulting in a collection of articles in Evolution and an Oxford University Press volume to correct just that. But let me make one more comment before passing on to others. The concept is second-order public good. So if innovation is good for the innovator, it's often because of what other people in the group are doing by bestowing benefits upon the innovator. And then we end up with the second order. Yes, it's true that the innovator is benefits within the group, but only thanks to these other traits, and those traits are also public goods. And so I think that unraveling is important and has been well rehearsed. I mean, super well rehearsed. So I think the situation in biology, and it's almost always been this case, is that there's a sizable community of people who get it. But that's like a bubble within a larger community, which doesn't get it. And also, I think that as far as human evolution is concerned, then cultural group selection is the mainstream, just as it is with philosophers. People like Joe Henrik and Michael Muthukrishna, and it's hard to find an exception actually, as people who disavow the importance of group selection and cultural evolution, interested in the opinions of others.
Mm-hmm. Your comment about the benefit that innovators may receive and the donation of those benefits as an altruistic act reminds me of our discussion of punishment in our book Unto Others, where punishing people who are selfish could be costly. It could be less costly than being altruistic. But then you need some sort of group selection to select for the punishing of selfish individuals.
Right.
If I may come in on this very interesting point, I think David's question is very relevant, and I agree with Elliott's answer. I think there's several things involved here. One is in the social sciences, we have individualism, which we can define as a view that the most important element in social stuff is individuals. That's a very loose statement, but that this idea is pervasive but always loosely formulated. So, I mean, one version of that idea is that explanation should be largely or wholly in terms of individuals. I don't think wholly is possible, but there's always a leaning to bring things down. Now, that's a special case of something in philosophy of science, correct me if you disagree, Elliott, called reductionism, where you say that chemists must go down to physics to explain everything going on in the chemical world, and biologists must go down to chemistry, and so people in the social sciences should explain in terms of biology. So everyone must go down and reduce as far as possible to elements below. E.O. Wilson, I think, promoted a version of this. I mean, I liked a lot of what I'm not hostile to him generally, but I think he was mistaken on this point. So that's a sort of scientific view which can live alongside a less individualistic ideology. It's the idea that proper science means breaking down to the smallest components all the time. And I would argue, and I have argued, that that's impossible because we have things called emergent properties, and emergent properties are based on relations and structures involving entities, relations between entities and structures of entities. And therefore, if you break down, you lose the structure, you lose the relations, and therefore you lose explanation. And the classic example is H2O. H2O is a combination of H and O in a specific way, which gives rise to the properties. And you cannot explain those properties, being watery, having a freezing point, and so on, of H2O without talking about that structure. Talking about the elements alone will not give you those properties. And that's old hat to a philosopher of biology, a philosopher of science, I know. But that would be my view. There's just two things here. Incidentally, I think with Dawkins, he's rather confused because he talks about both in the same book, selfish individuals and selfish genes. And it can't be both, because there's even examples discussed by him of birds being altruistic by signaling predators being close, where the bird is not being individually selfish, but the selfish gene explanation has something to go, as Dawkins puts very clearly. But he confuses those two things. They're not the same things. Selfishness of a gene is not the same thing as selfishness of an individual. Could be, but not necessarily.
Well, can I jump in?
Yeah,
Go
please,
ahead, Elliot.
yeah.
You're the speaker.
Go ahead. I'll go next.
If we're going to showcase Simpson's paradox, we also need to showcase the averaging fallacy, which is not quite the same. This way that if you basically average the fitness of individuals across groups, then what appears to be altruistic when you're doing a comparison within groups permutes to selfishness when you average the fitness of individuals across groups. It's for that reason that in your two-person example, Elliot, that's just you were accounting game theory. And in game theory, what's traditional is to average the fitness of lower level units, individuals across pairs, in which case tit for tat, which never wins within groups, does win all things considered. So I think the average fallacy needs to be brought to people's attention just as much as Simpson's paradox. And then in answer to Jeffrey, to your comment, it seems to me there's two strong arguments against reductionism. And Elliot has eloquently talked about this, written about this. One is the emergent properties, as you said, using examples like water and salt, but the other is ultimate causation, the very ultimate proximate distinction in the concept of downward causation is what's holistic, not reductionistic. And so, I mean, it's so elementary that I get stunned by how elementary it is. Is it possible that smart people, after all these years, are not making the distinction between proximate and ultimate causation? Can that be? But it is. I mean, it's just like shocking.
Elliot.
On the comment about the ideas about reductionism, I thought I should mention that group selection does not reduce to individual selection if you define them in the way I described at the beginning, where group selection is selection among groups and individual selection is selection within groups. The idea that there's group selection does not get captured just by talking about individual selection. It's a different kind of causal mechanism entirely. And to connect with what David was just saying about the averaging fallacy. If you say that all you mean by individual selection is that the average, if altruists are on average fitter than selfish individuals, they'll evolve by individual selection. And if selfish individuals are fitter than altruists on average, then that's individual selection too. So you then sort of collapse anything. Then what you're basically doing is saying that whatever evolves, I'm going to call that individual selection. And it obliterates the separation of these two levels, which are conceptually independent of each other. You can have group selection without individual selection. That would be a case in which groups vary among themselves, but each group is internally homogeneous. And you can have individual selection without group selection. The individuals vary within groups, but the groups have the same percentage of altruists across them. So you got to start with the idea of these concepts are conceptually independent, and then work with that. Otherwise, you're just going to do what the averaging fallacy tells you to do. That whatever evolves, you're going to say, oh, that's not group selection, or say that's group selection, or say that's genic selection.
Yeah, thank you. Anyone else like to come in? I've got a question for you, Elliott. Have you published this paper, or is it planned for publication?
No, it's there's a chapter in the book that I had on the screen at the start of my talk, Does Darwin Write the Origin Backwards? There's a chapter on group selection and individual selection and his views about that. And in other publications, I maybe too many times talked about the bearings of Simpson's paradox on this. So no, this isn't this is not the basis of a paper I plan to publish now. Yeah. I did it already.
Okay, thank you.
Could I ask Elliott, and if no one else has questions?
Yes, David. Yes, David. Please do.
But in your in one of your essays, you actually worked through all 6 editions of The Origin of Species, and you showed that Darwin kind of this importance of community level selection kind of dawned upon him gradually, which you showed over the course of the editions. Could you say a little bit more about that?
Yeah, that was one of the fun bits of research I did by using the Variorum edition of The Origin of Species. You can see edition by edition all the changes, and he, in the course of the 6 editions, the benefit I think the passage was about I can't remember whether it was about human morality or about sterile insects. I think it was probably the human morality. That wouldn't be the origin. That was it's another passage. I can't remember which one. And it has a kind of in the first edition. It's you wonder rightly whether he's talking about group or individual selection, but in the process, in the revisions that follow that, he's getting clearer and clearer about it. And by the end, he's really it's unmistakable that he's talking about group selection here in the modern sense of that term. So here's back to this the sociological question. I think a lot of people look at Darwin's first edition as the canonical one and regret certain things that he did in subsequent editions. And when you teach this book, you typically philosophers and historians of biology use the first edition. So it was a work in progress, although the treatment of the social insects, the sterility and the social insects, worker sterility, that's not ambiguous at all. So, but this other passage was, he worked on.
Another question that could be asked is what the fathers of population genetics thought. And my reading of it is that in the first place, they didn't think much about it because I think they had so much more to do in terms of just laying out the whole framework for population genetics. They didn't really consider altruistic social traits very much. But when they did, they converged upon group selection just as Darwin did. You take Sewell Wright's model in 1945, and then you take, I think Fisher has the equivalent with mimicry, I think. And so when they did encounter this fundamental fact that prosocial behaviors are not good for the prosocial individual at the most local scale, they too converged upon group selection. And in Wright's case, and that was just a little model he wrote in a book review. There's a quote which says, it's indeed difficult to see how this could evolve otherwise than by group selection. So I don't know if you've made a study or anyone else here has made a study of the population genetics field, and when it comes up, not Darwin, but anyone else who considers prosocial behaviors and just encounters their vulnerability within groups. It just can't be otherwise.
Yeah, I agree with you. The number of pages that the founding fathers of population genetics devoted to group selection is a handful of pages. It's not much of anything, with the exception of Sewell Wright. One of the things that I think helped the anti-group selection movement to be so powerful was the absence of mathematical models that they thought were regarded as grounding the idea and making it intelligible. And I think this was part of what made Hamilton very suspicious of it. He said, "Show me the model." Of course, eventually he did see a model of a mathematical model of how group selection would work from Price, and that helped him to say, this now makes sense. But so what was happening was there was this division between what we might call mathematical theorists and, for want of a better term, field biologists, who often find in the history of, the 20th century history of evolutionary theory, the latter group, in their observations, found that the most natural thing in the world to talk about traits evolving because they're good for the group without having a mathematical model of that. And there wasn't really one that was out there that could be picked up and applied. And that vacuum, in a perfect world, would have triggered the development sooner or later. Well, David, you helped do that, of a mathematical model. But what happened first was the wholesale rejection of the idea in the 60s with George Williams and for a while Hamilton and Dawkins's selfish gene. So it was the absence of a model that really, really made a big difference, I think, for this sort of sociology of this question.
Yeah, and I think
can I ask, Marion had a hand up earlier. Do you want to come in, Marion?
That's
Marion,
okay. I was just going to mention the Price-Hamilton thing and so on.
Oh, great. Excellent. Yes.
One little quick question. You have a new book coming out, I see. Elliott, is that right? Cambridge?
Well, it came out last year. It's called The Philosophy of Evolutionary Theory.
Okay, I just found out about it now. I'm looking forward to it. It looked from the Cambridge's summary as if it was all very traditional topics like fitness and units of selection and so on. Are you at all into the extended synthesis and some of the stuff that's going on about evolution and development and so on, or not?
I'm interested, and I like these new developments. That you're right. That's not in the book. I in retrospect, I kind of regret not doing it. I had a tight page limit to work with. Maybe I can use that as an excuse. There are some other things that are in there which are new for philosophers of biology, I think. I mean, there's a discussion of Fisher's geometric argument for gradualism, which I think is a fascinating thing. And population geneticists have gone over that, and I think they've recognized the flaws in the argument, but it's not widely recognized at all. And there's some material on how drift and selection are related and how you should think about which of them was a stronger influence on the evolution of a given allele. So there's some topics in there that are new for me. Group selection and phylogenetic inference. You know, I've been working on that for many decades, but there's some new things there too.
Okay, well, I'm sorry I missed it, and I'll still get it. Are you going to
Well,
be at
thanks.
ISH this summer?
I hope so. Yeah.
Good.
Hope to see you there.
Thank you.
Okay, thank you. Anybody else like to ask a question? Okay, a quick one from me. We have a bit of time. Elliott, how much do you think the problem for Darwin was? Well, obviously he was grappling with new ideas and reformulating them, but as we all know, he didn't have a sufficiently clear understanding or knowledge of genetic, what we now call genetic inheritance, okay? And he sometimes blurs the line between what we now call genes, he didn't, of course, and culture. And there's a kind of Lamarckian story as well going on. Because he didn't have those conceptual tools to make a clear separation between genetic transmission and cultural transmission, did that create problems for him? What's your comment on that?
You're right. He didn't have he was very wise not to put his theory of pangenesis in the origin. He would have been sticking his neck out unnecessarily. He just used what he calls the strong principle of heredity, which is just that offspring tend to resemble their parents. Yeah. And of course, that in its verbal formulation could be because of teaching and learning and imitation, or it could be because of, you know, the transmission of genetic material that leaves that the mechanism of transmission open. I'm not aware of how, at least in connection with issues about group selection, that was a problem for him. My colleague and friend in France, Michel Voya, has written about some of the very weird ideas that Darwin had about reproduction. And Michel argues that this really prevented him from thinking very clearly about sex ratio evolution. But that's a project that Michel has undertaken. I sort of thought that Darwin got a long way with the simple idea of this strong principle of heredity, and I don't see that it tripped him up.
Yeah, but you yourself use this distinction between genetic and cultural transmission, and it's central to Henrik. I like Henrik's 2004 paper on this, Joe Henrik, makes it very clear with mathematical language as well. And Darwin, not for understandable reasons, didn't have access to those concepts.
Right. He also, I mean, another thing that we know he got wrong is that he believed in the Lamarckian idea of inheritance of acquired characteristics, which he called use and disuse. Yeah. And it's in there, but he separates it well from the way he thinks about natural selection. And so it's just this, you know, I think for a modern reader, it's sort of this oddity thing, but it didn't sort of ruin the big picture as far as us moderns are concerned.
Yeah, and of course, it's easy for us to say now in hindsight.
Yeah, right.
I mean, I think you do a great job on your talk to show that Darwin was much more rigorous than some of his critics give him credit. And no, they may extol his brilliance in other areas, but they have a blind spot on this one. And I think you brought that out very clearly. So thank you very much for that. It's been a great presentation, a great talk. I wish you all the best with your
Elliott, I have one more question.
Yeah, so please go.
I appreciated David's question. I have to, and I'm going to now look up. That sounds very interesting. Your comparison across editions of Darwin's work. Related to that, Alfred Russel Wallace. Can you share with us how, how Wallace's ideas on any of these kinds of topics related to Darwin's thoughts, especially maybe Darwin's development of thoughts?
I'm afraid I'm not super up to speed about Wallace scholarship. One thing that comes to mind is a disagreement between Darwin and Wallace about whether the reproductive isolation of species from each other was due to natural selection. And Darwin regarded it as just a byproduct of individual selection. And Wallace, thought that it's a process that explained that there's an advantage to the species for individuals in it to be unable to reproduce with individuals in other species. Species that have this characteristic persist, and species that do not sort of fade into the background and get diffuse. So that's an example in which they disagreed about units of selection. And Darwin did not embrace higher level selection in this case of talking about species selection for reproductive isolation.
Great, thanks.
Okay, final call then. Anyone else like to come in? Okay, thanks again, Elliott, for that talk, very stimulating talk.
Thank you. I enjoyed participating in the discussion.
Okay, thank you, everyone.